User authentication and cross-site scripting. So let's begin with an introduction. Who am I? Well, I am Taylor Bean, and I am a computer science major. I'm also an undergraduate learning assistant for Dr. Gerber's Discrete Structures class. I was the project manager and full-stack developer for my Processes for Object-Oriented Software class, as well as being an avid hackathon participant. In all of my projects, I spend a lot of time working on security, and most specifically, the problem I feel most all developers face is how to handle user authentication. So let's quickly go over what is user authentication and why do we need it. So, authentication for what? I like to think of this as a three-pronged problem, with the first being data persistence. Modern applications must store data associated to users. If the application isn't storing data and isn't manipulating data, then I can argue that your application doesn't really do much. Of course, we can make the argument that data can be stored in local storage, but then that would bring us to part two, which is that data needs to be synchronized across devices for it to be a modern application. Thus, that gives rise to the database that we all know and love today. And databases can be designed in a whole bunch of cool data models and structures, but that's for another presentation. Part two of our three-pronged problem will be data manipulation. How do we manipulate the data that is on this database? How do we get it? How do we manipulate it, right? This gives rise to the API, and that stands for Application Programming Interface, and can be thought of as the connection between the backend of an application and the previously defined database. An example would be if we sent a request to the register endpoint, we would need to contain the necessary information to create a new user, and the server would create this user and respond accordingly. So that leads us to the third part, authentication. Now that we've created our API endpoints or routes, how do we really know who's using them, right? And also, not all of these requests are created equal. And what I like to say about that is there might be some API endpoints where we don't want every user to be able to use it. It might be like an administrative function, or it might be a function that we only want like developers to be able to use. So not all requests are created equal. Some only certain users are allowed to use. And so how do we make sure that only those users are using them? That's where user authentication comes in. So with perfect authentication, we can ensure the confidentiality, availability, and integrity of our data. And that is why user authentication is so important. Moving on. So types of authentication. You'll notice that there will be two types of authentication. And the first would be the cookie or session-based authentication. So after a successful login, a session is created by the server. The session ID is then passed back to the user and stored in the form of a cookie. Sessions can be revoked by the server at any time. And that's the benefit of using this method, is that all sessions are controlled by the server, meaning that a session can be revoked at any time. And this can be visualized in the log out of all devices button seen on many modern applications today. Then we have our token-based authentication method. And so after a login, a stateless token is created by the server. The key difference here is that the token is stateless, meaning that the server does not store or alter the token that was created. And this decouples the authentication from our database, which allows for more scalability. Once the token is passed back to the user, it is most commonly stored in local storage, but it can also be stored in a cookie as well. Save some physical limitations that we'll get into later. So you might ask, how do we associate a given user to the supplied JWT, which is a JSON web token, which is the most popular form of token used today? And so the token is encoded and signed to contain this user info. A key thing to note here is that encoded is different from encrypted encoded in order to recover the information, you need only know the algorithm used to encode it, whereas encrypted you will need your secret key as well. So it is recommended that you do not contain any sensitive information in a token. So which method is more secure? It's actually a hot topic, just like most opinion-based computer science topics. The cookie advocates claim that local storage is vulnerable to XSS attacks, which is cross-site scripting attacks. And the token advocates claim that cookies are vulnerable to both XSS and XSRF, which is cross-site resource forgery attacks. And there are also some practical limitations to consider. So, like I said before, cookies have a size limit of 4 kilobytes, and comparatively, tokens can be much larger, infinitely large, depending on how much information you want to encode inside of the token. So each request must have the token attached to it. So the smaller the token size, the more efficient the request and response is going to be. Thus, you would want to make your tokens as small as possible. And if they're smaller than 4 kilobytes, you can even store them as cookies as well, like I mentioned before. But if you do store them as a cookie, then you are still vulnerable to the XSRF attack. So I do not recommend doing that. So now we get to our attack vectors. We have our cross-site scripting, and we have our cross-site resource forgery. In the coming slides, I will discuss cross-site scripting in depth, but I will not have time to cover cross-site resource forgery. So what is cross-site scripting? Simply, it allows for an outside actor to execute code, in this case JavaScript, on the website or application. If the user had already authenticated, then the bad actor can send malicious requests on the user's behalf. A practical case of this would be, consider you're logged into an e-commerce site. Then the bad actor could add items to your cart and ship them to him or herself. And there are many types of cross-site scripting attacks. There is the reflected attack, which is when an API response contains tainted input from the request, and typically this response is rendered to the DOM in some way, which would cause the script to be run. Then there is a stored XSS, which is when the tainted payload is stored in the database, and you can imagine that this would result in a widespread cross-site scripting attack, since the script would be run each time that data is requested or read from the database. And finally, we have the DOM, which is when cross-site scripting occurs from user input. And I will demo that now. So here we are in the demonstration portion, and this is just a very simple web app I made in React. So up here, we're going to see a plain text representation of this text area. And down here, I dangerously set the inner HTML of this h1 tag. What does that mean? Let's try typing in an input tag, and you'll see instead of rendering text, we will render the input over here. And that's perfectly capable of taking input. That is a very simple form of cross-site scripting. Let's see something a little bit more complex. So now we have a button that will run a very simple script. It's just going to alert us that XSS has occurred. So let's see if this works. And it does work. XSS has occurred. And you can see how, instead of just alerting, we would be able to run some like API requests by using like the fetch API. And you would be able to include the cookie data or the token data inside of the header for this request, which would authenticate you as the user logged into this browser. So now that we've seen a cross-site scripting attack in action, let's take a look at how to prevent one. So you'll see this little code snippet from the demonstration that I just did, and you'll see that I had to dangerously set the inner HTML. And this leads us to the fact that most modern frameworks come with default input sanitation aimed to combat code injections of all kinds. And that's what I did. So remember when I said that security experts claimed that cross-site scripting was less dangerous simply because we understood how it works. This understanding has allowed us to create an abstraction layers for web development in the form of frameworks like Google's Angular or Facebook's React.js. And as such, I would recommend using one of these frameworks instead of writing vanilla HTML and JavaScript, as they've been built to catch the most common vulnerabilities for you. There's another popular defense, and that is to store the token in memory, such as a JavaScript variable or a constant, and instead store the refresh token in local storage instead. This refresh token is only able to request another authentication token from the server. And this just adds another layer of security. So think defense in depth. And now we're on the conclusion. So, if you're a web developer and you're using a modern framework, chances are you have nothing to worry about when it comes to code injections or cross-site scripting. Additionally, when it comes to cookies versus tokens, cookies do serve a purpose, but I would argue that tokens might perform better for authentication purposes. But this should always be decided on a case-by-case basis. I really do hope that you've learned something about authentication and cross-site scripting. Thank you, and have a nice rest of your day.